Today we're going to read about electrolysis. It's in volume 8. It's mentioned on page 2730. It says electrolysis, see electrochemistry. So that's what we're going to read about. There is no photo for electrochemistry, but there are some other really cool photos, and I'm going to include them along with the photo from the front cover, which is ancient Egyptian papyrus. Sections from the papyrus of Ani in the British Museum. The soul of the scribe Ani, who died in the 18th dynasty, here appears in the judgment hall of Osiris, where the decision is about to be made as to its eligibility to enter paradise. Huge electric arc furnace used in the production of stainless steel and other alloys. These next three are just listed as figure 1, 2, and 3, so I won't be talking about those. There's a large section on electricity. This next one says, drawing showing principle of a transformer. Alternating current in a coil. A creates magnetic field in the core. C, this field induces current in secondary coil. B, the voltage is higher in B due to more turns in the coil. The next photo is modern chemical transformer changes the voltage of large quantities of electricity. Variable condensers used for tuning radio transmitters. Top, plates closed giving maximum capacity. Bottom, plates partially closed giving partial capacity. Early electric lighting. Left, a form of arc lamp used for street lighting in late 19th century. Middle, arc lamp required complicated mechanism for maintaining proper distance between carbon sticks, since points burned away as the lamp was used. Right, first Edison incandescent lamp to be used commercially, produced in 1879. I love these old photos. This next one is just listed figure 1. And it's in the electronics section. The next photo, partially completed tube used in electronic induction, heating to produce mirror smooth tin plate. Cathode and grid are in place. Anode has not yet been attached. Electronic devices used in industry, above 1500 ton hydraulic press, timed by simple electronic timer like the one shown at lower right. Right, in the manufacture of paper, a photoelectric tube is attached to an electronic amplifier, which actuates mechanism for keeping paper centered as it passes over a roller at high speed. And the last photo is workroom in an electroplating plant. The bath is at left. Behind it is the electric control panel. Men are engaged in various steps of dipping and washing metal objects. Electrolysis. See electrochemistry. On page 2728. And here we go. Electrochemistry. That part of the science of chemistry which deals with the interrelationship of electrical currents and chemical reactions. In the broadest sense, electrochemistry is the study of chemical reactions which produce electrical currents and of the chemical reactions which are caused by the action of the currents. Radiochemistry, the chemistry of radioactive compounds, is closely related to electrochemistry. Most inorganic and some organic chemical compounds, when in a molten state or when dissolved in water or other liquids, become ionized, i.e. their molecules become dissociated into positively and negatively charged components, which have the property of conducting an electric current. See ionization. If a pair of electrodes are placed in a solution of an electrolyte, an ionizable compound, and a source of direct current is connected between them, the positive ions in the solution move toward the negative electrode and the negative ions toward the positive. Reaching the electrodes, the ions are freed of their electrical charge and transformed into neutral atoms or molecules. The action of a current on an electrolyte can be understood from a simple example. If the salt, copper sulfate, is dissolved in water, it ionizes into positive copper ions and negative sulfate ions. When a source of current is applied to the electrodes, the copper ions move to the negative electrode, are discharged, and are deposited on the electrode as metallic copper. The sulfate ions, when discharged at the positive electrode, are unstable and combine with the water of the solution to form sulfuric acid and oxygen. Such decomposition caused by an electric current is called electrolysis, Greek, Lysis, loosening. In all cases, the quantity of material evolved at each electrode when current is passed through an electrolyte follows a law discovered by Michael Faraday. This law states that the quantity of material transformed at each electrode is proportional to the quantity of electricity passed through the electrolyte, and that the weight of the elements transformed is proportional to the equivalent weights of the elements, i.e., the atomic weights of the elements divided by their valences. See chemistry. All chemical changes involve a regrouping or readjusting of the electrons in the reacting substances. Hence, all such changes may be said to be electrical in character. To produce an electrical current from a chemical reaction, it is necessary to have a reducible substance, one which gains electrons easily, and an oxidizable substance, one which loses electrons easily. A reaction of this kind can be understood from the operation of a simple type of electrochemical cell. If a zinc rod is placed in a dilute solution of sulfuric acids, the zinc, which oxidizes readily, will lose electrons, and positive zinc ions will be liberated into the solution. The free electrons stay in the zinc rod. If the rod is connected through a conductor to a copper electrode placed in the sulfuric acid solution, the electrons will flow around this current into the solution, where they will be taken up by the positive hydrogen ions of the dilute acid. The combination of the electrons and the ions produces hydrogen gas, which appears as bubbles on the surface of the copper electrode. The reaction of the zinc rod and sulfuric acid thus produces a current in the conductor. An electrochemical cell of this kind is known as a primary cell. Cells of this type are usually known as voltaic cells. In the storage battery, or accumulator, commonly known as a secondary cell, electrical energy is fed to the cell from an outside source and stored within it in the form of chemical energy. The chemical reaction of a secondary cell is reversible, proceeding in one direction when the cell is being charged, and in the opposite direction when it is discharging. Because the reaction is of this type, a secondary cell can be recharged and discharged again and again, whereas a primary cell is often useless as a current source after the chemical reaction is complete. Industrial applications. Electrolytic decomposition is the basis for a number of important extractive and manufacturing processes in modern industry. Caustic soda, an important chemical in the manufacture of paper, rayon, and photographic film, is produced by the electrolysis of a solution of common salt in water. The reaction produces chlorine and sodium. The sodium in turn reacts with the water in the cell to yield caustic soda. The chlorine evolved is a valuable byproduct used in pulp and paper manufacture. An important industrial use of electrolysis is in the electrolytic furnace, which is employed in the manufacture of aluminum, magnesium, and sodium. In this furnace, the resistance of a charge of metallic salts is used to heat the charge until it becomes molten and ionizes. The metal is then deposited electrolytically. See electric furnace. Electrolytic methods are also employed in the refining of lead, tin, copper, gold, and silver. The advantage of extracting or refining metals by electrolytic processes is that the deposited metal is of great purity. Electroplating, another industrial application of electrolytic deposition, is used to deposit films of precious metals on base metals and to deposit metals and alloys as strengthening or wear-resistant coatings on metal parts. That is all it has to say about electrochemistry. I thank you for listening. I hope you have a fabulous day. Sincerest, Kimba.